The other thing that can happen with these functions, I've rotated everything so far either around the x-axis or around the y-axis. I could rotate around x equals 1 or y equals 3 or something like that. I can take a function like, let's say I've got y equals x squared again, okay? Well, we know what that looks like, and I'm going to restrict this and only go from 0 to 3 this time, okay? So it's something like this. And what I said before is, well, I'm going to rotate that around the y-axis, would form like a bullet shape pointing down. I could rotate it around the x-axis and it would form something that looked like this, okay? Kind of like a spinning top almost, if you looked at it from the side. But instead of doing that, this time I'm going to rotate around, let's say x equals 3. Now if I rotate this around x equals 3, first I have to identify where's x equals 3. X equals 3 is right here. I'm going to rotate around that. I'm going to make like, kind of like a volcano here, right? Well, it doesn't have a hole in the middle, but rotate it that way, it forms a completely different object than if I rotate it around that axis or this axis, okay? Very different. But the entire process is the same. Once I choose what am I rotating around? X equals 3, okay. What do I need to find? I need to do a slice. What's that slice looks like? That slice looks like a circle. And I identify, in this particular case, it's going to be a circle without a hole. If I'd have rotated around x equals 4, it would have had a hole in the middle, right? No hole here, okay? It's just going to be a circle. I need to find out what is that distance right there, because that's the radius. And the radius is going to dictate what the area is, and the area is going to be what goes into my integral. But I have to be careful because notice, that radius is not from here. It's not the entire x distance. It's only from here to here. It's from 3 to there, or from 3 to there. Actually, because I was talking about this, okay, this was my original function, I look at that and I say, okay, I need to look at what that distance is right there. It is an x distance, okay? But whatever x distance it is, it's starting from 3. So although that's an x distance, it's not x, it's 3 minus x, right, to get here. It'd be 3 plus x if I went over there. So the radius is 3 minus x. Of course, my area is pi r squared. So this is going to be pi times 3 minus x, quantity squared. However, this slice right here, I've sliced in the y direction. I need things in terms of y. I say, uh-oh, I need things in terms of y. Well, to get things in terms of y, I said this was 3 minus x, and it's not false that it's 3 minus x, but I don't care that it needs to be in y, in terms of y. So again, I look at this and I say, well, y, square root of y is equal to x. Well, that's true. So, 3 minus x, if I put that in terms of y, it would be 3 minus square root of y. And so this area, 3 minus square root of y, 1d squared. And so I'm going to need to do some more math here with the area before I get there. I'm going to go ahead and FOIL this out. First times first is going to give me 9. In and out, both going to give me this. Or both going to give me minus 3 radical y, so 2 times that. And then I'm going to get a y. That's the thing FOILed out. And now that is the area. I'm going to integrate. I would say what I'm going to integrate from where to where yet. I'm not worried about that. I'm going to put the area in here. Pi, I've got 9 minus 6, and I'm going to write this intentionally as y to the 1/2 because I like raising the power by 1 and dividing by it, and that's the right form to do that. And where's my integral going? From where to where? Well, it's going from here, right? I'm adding up all of these slices, all the way up from here up to here. Well, what is there in terms of y? I know that that's x equals 3, but that means that's where y is equal to 9. So I'm integrating from 0 to 9 to get that volume. Now I can actually do this. Up to the power of 1 and divide by it, I get things like 9y, 6y to the 3 halves. I can divide by 3 halves. That's the same thing as multiplying by 2/3. Y squared over 2. And into all of this, I need to plug in 9 and 0. Again, fortunately, since this isn't a sinusoidal function or something, zero is just going to, everything's going to go away there. But I'm going to go ahead and do this. Pi, I plug in 9. I've got 81 minus. Well, what's going to happen here? I'm going to end up with that cancel. I'm going to have 4. So I got 4 times y to the 3 halves. Well, y to the 3 halves. 9 to the 3 halves is 9 to the 1 half cubed. So square root of 9 is 3. Cube it, I get 27 there. 4 times 27. And then plus, looks like 81 over 2 over here. Four times 27, that's 108. So I have minus 27 plus 81 over 2. So I've added these two, 108 minus 81 is minus 27. So I've got that, and 27 is minus 54 over 2 plus 81 over 2. And that looks like 27 over 2. 27 pi over 2. And that's my volume in there. The important part to take from this is we go through exactly the same process right here. It's just we can't be lazy and say, well, when it's in the x direction, that's going to be x. When it's in the y direction, that's going to be y. We can't do that because we have to look at that and say, it is in the x direction. However, the radius is not from x equals 0 out to there. The radius is from this center, so we have to look and either do 3 minus x, or we could have done, that's 3 plus x also. And turns out that would have given me the same result if I had done that, because I could have this curve rotating around this, and it would give me the same, values. Since I'm squaring it here.